The exciting conclusion of our volume and surface area unit has finally arrived here. We have volume of spheres. Whew, exciting. I mean, this is like almost as exciting as like a season finale of your favorite show, but it's math, right? And of course, included in the spheres, we will have our hemispheres. Let's do this. So we have two wonderful formulas here for our volume of a sphere. It is 4 pi r cubed divided by 3. And the hemisphere is just half of that, 2 pi r cubed over 3. And if you're like, well, hold up, wasn't the surface area formula like a little bit different? It wasn't actually half. Well, when you're cutting something in half as far as volume goes, you're just literally cutting it in half. With surface area, you're creating a new surface when you cut something in half, right? So they are different. But here, 4 pi r cubed over 3, and hemisphere is 2 pi r cubed over 3. Let's do it. Oh, did you think that we were just going to ask you to find the volume given the radius? You're hilarious. It says the volume of the sphere is 288 pi centimeters cubed. Find the radius of the sphere. We give you the volume. How wonderful of us. Or no, maybe that's inconvenient. So if I take that volume and I set it equal to my radius set it equal to my formula, which is 4 pi r cubed over 3, well, I could solve algebraically this fun little math problem here, right? Well, first I got to multiply by 3 on both sides. So multiply by 3, multiply by 3. 288 times 3 gives me 864 pi equals 4 pi r cubed. Well, I'm going to notice that these pi's, they're going to cancel, right? They're gone. They're out of the picture because if I divide by pi, it just cancels out. Now I need to isolate that r cubed. So if I divide by 4 on both sides, so divide by 4, I'm going to get 216 is equal to r cubed. So how do I undo cubed? I've undone squared before, right? I use a square root. Ooh, perhaps I use a cubed root. All right. So if I take the cube root of both sides, that's going to cancel out the cube. You may remember that from Algebra 1 now, maybe not, whatever. Now we're going to remember it now. Okay. So cube root of 216. Well, how do I type that in my calculator? You can hit the math button and select the cube root. You'll see it in there. It's one of the third or fourth option or something like that. My preferred method is I take 216 in my calculator. I just type it in 216, and then I raise it with my exponent to the 1/3 power. Raising to the 1/3 is the same as cube rooting. Raising to the 1/4 is the same as fourth rooting. Raising to the 1/5 is the same as fifth rooting. Raising to the 1/2 is the same as square rooting. So I can use those exponents, and I think that's a little bit easier when typing into the calculator. So I prefer that method. However you go about it, you're going to get an answer of 6 for my radius. Boom, done. We have 6 centimeters for my radius of that sphere. Whew. Man, that was a good one. That was a good one to start with. Really caught me off guard there. So we have a hemispheric dome. It has a height of 30 meters. We want to find the volume of the dome and then find the surface area of the dome alone. Okay. Well, this is, have you ever seen like maybe some of those sports facilities and stuff like that? That like it's a dome type shape. So we have a circular base and then we've got ourselves a little hemisphere. And the height of that is 30 meters. Well, the 30-meter height, if we actually think about this in the context of like our math type of problem, this is actually our radius of that hemisphere as well. If you thought about this as like a full sphere, this is just going halfway across the sphere. So my radius is 30. Awesome. That's the only dimension that I need to find the volume of a hemisphere. My volume of a hemisphere is 2 pi r cubed over 3. So if I plug in the 30, 2 pi times 30 cubed over 3. And I'm going to go ahead and plug this into my calculator here because these numbers are a little big. But hold up, on second thought, maybe I don't need my calculator. Let's think about this for a sec. 30 cubed. Well, I could do 3 cubed, right? At 3 times 3 times 3 is 27, and I got those 3 zeros there. So that's going to be 2,700. So 2 pi times, 27,000, right? 3 zeros all over 3. Well, what's 27 divided by 3? So I'd have 2 pi times, and that would be 9 1,000, right? You just kind of like ignore the zeros a little bit to work with some smaller numbers. And what's 2 times 9? Well, that's going to be 18. Now, 1,000 pi meters cubed. All right, we were able to actually do that without a calculator. Okay, awesome. So, sometimes those numbers look a little scary, but with a little bit of thought, a little bit of confidence, you can actually manage them quite well without that calculator. Now, what is the surface area of that dome alone? So they're saying the surface area of the dome alone, we're referring to just the hemisphere, but without the base. So that would be 2 pi r squared. Okay, that would be our surface area formula. When we include the base, it's 3 pi r squared because we're adding in an extra circle, pi r squared. So for this one, we're going to have 2 times pi times my radius, which is 30, squared. 3 squared is 9, so this is going to be 900. So 2 pi times 900, and then times 2 is going to be 1,800 pi, and that would be meters squared because we're talking surface area. All right. And if we wanted approximations here, we could get that by plugging them into our calculator with the pi button, but I think we're all good with exact numbers here. So we have an ice cream cone that is 9 centimeters deep and 4 centimeters across the top. A single scoop of ice cream is 4 centimeters in diameter, and it's placed on the top. If the ice cream melts into the cone, will it overflow? My goodness, I could not see of a better application problem as we gear our way towards the summer here. I mean, this is something you're going to be thinking about. If you get an ice cream cone, you'll be like, whoa, if I don't eat this fast enough, is this going to melt over? Whew. All right, let's figure this out. So my cone would look something like this, right? I'm going to draw it in the orientation of a cone where it's upside down. It says it's 4 centimeters across the top. So I think our important to mention there is that our radius would be 2. And then the cone is 9 centimeters deep. So this is 9. Well, could we figure out maybe what the volume of that cone is? Because that's what we're talking about here is the volume. We want to find out the volume of the ice cream, the volume of the cone, see if that volume of that ice cream would fit into that cone. Well, my volume, as we know, is big B times H over 3. My base is pi times my radius of 2 squared. My height is 9 all over 3. What was that going to give me? Well, I could simplify the 9 to the 3. So I'd have 4 times 3 is 12 pi. So that's my volume of the cone. Let's find the volume of our sphere now. The diameter is 4, so that means my radius of the sphere is 2. And my formula is 4 pi, volume equals 4 pi r cubed over 3. So 4 pi times 2 cubed over 3. Well, 2 cubed, now I don't have any simplifications here. 2 cubed is going to be 8. So this is going to end up being 4 times 8, which is 32 pi over 3. All right. Well, I guess once again, my simplifying on the fly didn't really help the situation. I tend to like to do that just because it makes the numbers a little smaller. But we could say this is equivalent to 36 pi over 3, couldn't we? Right? Now, that's a little bit easier to compare. 36 pi over 3, 32 pi over 3. The cone has a larger volume. So will it overflow? No, it will not. Yay. It'll all fit in the cone. That's wonderful. You could also have plugged this in and gotten a decimal equivalent in our calculator. That would have been another option versus getting that common denominator that we got right there. All right, we got ourselves another composite solid here. This time we have, it looks like a hemisphere with a cone attached to it as well. So we want to find the volume and the surface area, a little bonus action. Okay. So let's see here. I'll go with my hemisphere first. I'll do that in red. The volume of the hemi. All right. And that is 2 times pi times my radius. Do I have that? I absolutely do. It is 5 cubed all over 3. Cool. Well, 5 cubed is 125 times 2 is 250 pi over 3. That is an odd looking 3. That's inches cubed. All righty. So there's my volume of my hemisphere. Let's find the volume of the cone now. I'll do that in blue. Well, it looks like I actually need something else because if I'm going to do the area of the base, which is pi times my radius of 5 squared, I need the height, right? Big B times H. Well, this is a 5, 12, 13 triangle, isn't it? Excellent. I'm sure you all remembered your triples. So boom, I've got my height. How easy was that? I didn't even have to do the Pythagorean theorem because I remembered my triples. All right. So 5 squared is 25. 25 times 12. And I'm noticing that I don't want to reduce. I'm finally noticing it on this one because if this is over 3 and this is over 3 and I want to put them together, I want a common denominator, right? So this ends up being 300 pi over 3. And if I add those two together, the volume, the total volume is going to be, well, 250 plus 300 is 550 pi over 3. It's a terrible 3 again. And that would be inches cubed. Cool. So there's my total volume. And I noticed I didn't put any units here. Not that it was my final answer, but I'm gonna pop them in there, just for good measure. All righty. So let's move into surface area. Well, let's start with the surface area of, and I'll just do an A for surface area of my hemisphere. Well, the area of that is, am I including the circle? I'm not. So this is just going to be my 2 pi r squared, so 5 squared. That's all I'm going to have for my hemisphere because I'm not including that circle base. That circle's inside the figure. So 25 times 2 is 50 pi inches squared. Excellent. And now I just need to find out the area of my cone. Do I want the entire area of the cone or just the lateral area of the cone? That's correct. Okay, I just want the lateral area because, again, that circle is inside the figure. My lateral area is pi times my radius, which is 5, times my slant height, which is 13. So all this is 65 pi inches squared. So how do I get that total surface area? Well, I would just add those two together. 50 plus 65 gives me 115 pi inches squared. And if I wanted the exact, I can always plug this, if I wanted the approximate, I could always plug this into my calculator with that pi button. But this is my exact answer. There's no rounding that has happened here. It is exact. All right. Awesome. So here I want to find the volume of a sphere if the surface area of the sphere is 144 pi. Well, what's the only dimension that I need to find volume or surface area of a sphere? It's just the radius. So I need to set up some kind of an equation. Well, if we remember 4 pi r squared, that's my formula for the surface area. So if I set that equal to my known surface area of 144 pi, perhaps I can solve and find my radius. Well, let's see. If I divide by 4 pi on both sides, the pi's are going to cancel, right? And then 144 divided by 4 is going to be 36. So r squared is equal to 36. And if I square root both sides to solve, I'm going to get r equals 6. All right. Now, remember, when we are square rooting, there is a plus or minus. There are two solutions, but we're obviously going to omit a -6 as our radius. So I've got 6 for my radius. Now I want to find my volume. I'm going to switch colors here. Why don't we go with, I'm going to go with a custom color here. How about a slightly darker green, maybe? Let's see here what I can do here. Yeah, I think I'm going to go with something like this. Okay. So my volume is equal to 4 pi r cubed all over 3. So let's go ahead and plug my 6 for my radius in. So that's 4 pi times 6 cubed all over 3. So if you'd like, you can either plug that into your calculator. If you know 6 cubed is 216, and we divide that by 3, we're going to end up getting, let's see here, 288 pi. No units, units cubed. All right. When you're plugging these things in your calculator, if you want the exact, just leave the pi out of it, remember. So 4 times 6 cubed over 3 would give you 288. And then you pop the pi in at the end. You want to get your decimal equivalent, plug it in using the pi button. Last problem of the last lesson of the last chapter. Man, it's like the grand finale here, children. The grand finale of math honors geometry. Are you ready for it? It's going to be sad but exciting at the same time, you know? Okay, what is the radius of a sphere that has a volume of 972 pi? Well, the volume formula is 4 pi r cubed over 3. And if I set that equal to 972 pi, I can solve for my radius. Let's do a little bit of algebra. Well, I'm going to multiply by 3 on both sides first to get that out of there. So 972 times 3, I'd have 4 pi r cubed equals 2,916 pi. Whew. All right. Now, my pi's I know are going to cancel, and I'm going to divide by 4, but I'll just write that out algebraically. We'll divide by 4 pi. Boom, gone. So divide this by 4, and I get r cubed equals 729. So how do I solve for r again? We've done this once. If I were to either cube root these sides, which I could plug into my calculator using an exponent to the 1/3. So in my calculator, I'm going to do 729. Well, that's a terrible 2 there. 729 raised to the 1/3 power. This is how I personally like to plug it in. That way I don't have to go to a separate math menu. I'm going to get a radius of 9. Do we have any kind of, nope, no units. Units. Excellent. Boom. That is it. We are done with new content here. That's quite the accomplishment there, children. You have a wonderful day. We had a wonderful school year. America, freedom, rock and roll, and Costco as always. And make sure that you follow at River Dog Jenny on the gram. Have a wonderful day.